Welcome. Let's take a look at chapter 11.3. Continuing to use the limit definition to find the exact slope, but we're also going to take a look today at how to use derivatives to find those slopes. We've talked about how the formula for the slope of a graph, we could use the limit as h approaches 0 of our difference quotient. And that's how we'll start off. For our first example, x squared plus 2 is our function, and we're supposed to find the slope at two different points. Well, we could do a difference quotient, taking that -1, plugging in here, and working out our difference quotient to find our slope. Then we could find the point here, take 3, plug it in, and find the difference quotient to get our slope at that point. Because we're not just doing x1, y1, x2, y2. It's not a line. We have a curve. It's a parabola. And it's going to have different slopes at different points. So we need that tangent line. That sounds like a lot of work. Instead, how about we simply use our difference quotient? Our slope is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So if I were to take x plus h and plug it in here, x plus h squared plus 2, and then I would take x and plug it in here, you get back the original function, but we'll put it in parentheses because you're subtracting things off, all divided by h. So this is equal to the limit as h approaches 0. Might need to come off to the side and do x plus h squared. FOIL, x plus h times x plus h gives us x squared plus hx plus hx plus h squared. Like terms right there. X squared plus 2hx plus h squared. Don't forget there's a plus 2 up here already. Now we'll subtract off our x squared and subtract off our 2. Looking for like terms, things that can cancel. Well, x squared can cancel with x squared. 2 can cancel with the minus 2. So the limit as h approaches 0, starting to whittle down quite a bit. We have 2hx plus h squared. Well, as typical, these two have an h in common that we can factor out. Take an h out of here, take an h out of here, and we get 2x plus h. Your h's cancel. So the limit as h approaches 0 of 2x plus h, we are now ready to substitute in 0 for h. So 2x plus 0 is 2x. Our slope at any point is 2x. You have two different points. Your first point is -1. So the slope at this point would equal 2 times -1, which is -2. Our slope at this point would be 2 times 3, which is 6. Quicker than doing a difference quotient for this point and doing another difference quotient for this point. You can now use that slope 2 times x for any x value to get the slope at that point. That's called a derivative. What we found was the derivative of our function at x. Our derivative, which is often represented this way, f with a little prime, like an apostrophe there, of x equals 2x, is the instantaneous rate of change. So at a particular instant, at a single point, that's the rate of change. That's the slope. Compared to when you have y equals mx plus b, m is the average rate of change because you're taking those 2 points and you're doing the y2 minus y1 over x2 minus x1. So our derivative is the instantaneous rate of change, the slope at a particular point. Our derivative is the formula for the slope of the tangent line at a particular point. The derivative gives us the slope of the tangent line. The derivative is the instantaneous rate of change, meaning right now, what's the rate of change? Oh, right now, what's the rate of change? Instantaneous. The equation of our tangent line at -1, 3. Well, it's a line, right? So we could work off of y minus y1 equals m times x minus x1. Point slope form of a line. Take your x, take your y, plug it in here and here. Here's x1, here's y1. Then we plug them in. Y minus 3 equals, did we have anything for our slope? Well, yeah, remember the slope at that point was -2? X minus -1. So y minus 3 equals -2 times x plus 1. Y minus 3 equals -2x minus 2. Y equals -2x. Add 3 to both sides, plus 1. There's the slope of our tangent line at that point. What part of the limit as h approaches 0, sine of a plus h minus sine of a over h equals cosine of a don't you understand? Right? Right? All of it? How to do calculus. Write down the problem, cry. There you go. Calculus made easy for everyone. Let's find the derivative of 5x squared minus 3x. Our derivative, f prime of x, will equal what? Well, the limit as h approaches 0. Of our difference quotient, f of x plus h. X plus h going to go right here. Five times x plus h squared minus, oh, it gets to go here too! So exciting! There's f of x plus h. Plugged in x plus h here, plugged in x plus h here. Minus f of x. Well, if I take x and I plug it in here and here, I get back exactly what I started with. I just need to put it in parentheses. All over h. Hey, I have a great idea. How about I'll work out the bottom part, you work out the top part. Oh, sorry, Mr. Brown, you get to do it all today. Yay, lucky me. See, that's the part I would have normally done in class. FOIL, distribute, distribute. 5 times x squared plus 2hx plus h squared. Where did I get it from? I did x plus h times x plus h on the previous screen, and I just remembered my answer. Minus 3x minus 3h minus 5x squared minus minus makes plus 3x. Still need to distribute my 5's. Five times x squared, 5 times 2hx, 5 times h squared. Oh my goodness. Can I get a new notebook? Limit as h approaches 0. Looking for like terms. Anything that might simplify or cancel out. Well, let's see. 5x squared with minus 5x squared. Minus 3x and plus 3x. And it looks like we're left with 10hx plus 5h squared minus 3h. All of these pieces in red have something in common. They have an h in common. We can factor out that h. Leaves you 10x plus 5h minus 3. Well, cancel, cancel. And then we have the limit as h approaches 0 of 10x plus 5h minus 3. Plugging in 0 for the h. We get, let's see, 10x minus 3. There's your derivative. In other words, if I pick a point and I plug in my x value, I have the slope at that point. Derivative notation could be represented as f prime of x. If we're not using f of x, we're using y, you would see y prime, or you can also see the derivative of y with respect to x. dy dx, they all mean the same thing. They all represent the derivative, which is your instantaneous rate of change, which is your slope of the tangent line at any point. dy dx, f prime of x, or y prime, they all are derivative notations. And there's even another one that you'll see in calculus, but it's not really used as widely as these. Derivatives are one of the two main topics in Calculus 1. There's derivatives and there's integrals. They undo each other. How about you try to find the derivative for square root of x minus 1, then find the slope of the graph of f at the points 2, 1 and 10, 3 And since that's not enough, why don't you try to find the equations of the tangent lines to the graph at those points. Hit pause, come on back when you're ready. Limit as h approaches 0 will give us our derivative. We take f of x plus h and we replace the x with an x plus h. Minus, then we plug in x for our original function, which is simply our original function. Now what would you do? Well, you could try to plug in 0, but then that gives you square root of x minus 1 minus square root of x minus 1, which is 0 over 0, and that's an indeterminate form. We have seen how to rationalize. Let's try that. That looks like fun. If I were to multiply the top by its conjugate, then maybe I could get somewhere. Plus instead of minus. And then I have to do the same exact thing to the bottom. Whenever you multiply the top by, you multiply the bottom by. I don't know if this will work or not. Just trying it. Sometimes that's what you do. You just try. And you pray. And you cry. And maybe you get somewhere. H times this. And then we get to FOIL the tops. Square root of x plus h minus 1 times square root of x plus h minus 1 is x plus h minus 1. Radical times a radical, same radical, gives you back everything under that radical. Next, we would have this times this would give you a positive x plus h minus 1 times x radical x minus 1. Then you would have the same thing but negative. They cancel out. Lastly, we would have negative radical x minus 1 times positive radical x minus 1. So minus x minus 1. That's looking promising. Looking for things on top that might cancel. I'm going to distribute a negative here and a negative here. So we have x plus h minus 1 minus x plus 1. I see some things that cancel. X cancels with x, negative 1 with 1. We're left with an h on top. So I'm still getting 0 over 0, which is a problem. But I think we're getting closer to a solution with it. The h on top cancels with the h on bottom. We'll get the h out. Leaves you nothing on top, so there's a 1. 1 is a factor of anything. And on the bottom, we have x plus h minus 1 and x minus 1 in radicals. We should be able to plug in 0 for our single lone h at this point. I just need a bigger screen. You're like, I need more paper. Okay, so plugging in 0 here, I get 1 over square root of x plus 0 minus 1 plus x minus 1. Well, what does that simplify to? You have 2 of these, so you get 2 square root of x minus 1. There's your derivative. There is the equation where you're going to start plugging in x's to find your slope at this point, slope at this point. Plugging in 2. Over 2 radical 2 minus 1 square root of 2 minus 1 is 1. So 1/2. At our other point, which was 10 and 3, our slope would be 1 over 2 times 10 minus 1 square root of 9 is 3. There's our slope at this point. There's our slope at that point. The last part was to write the equations. You'll plug those slopes in. You'll use your x1 and y1 to write your equation. Y minus 1 equals 1/2 times x minus 2. The other equation, y minus 3 equals 1 over 6 times x minus 10. Wrap up with derivatives, and then I believe you guys have a quiz shortly. So have a great Viking day. Bye, guys.